Okay, so we've gone over graphing. Graphing was when we both had y equals, right? Because we had y equals mx plus b. That was the easiest way to do that, was graphing, right? Substitution is easiest when one of them solved for a variable like x equals or y equals and the other one's not. We can substitute that in, right? Now, we've seen them where they're both in standard form, like x plus y equals 72, right? When both equations are that way, instead of having to manipulate that equation so that you can substitute, we can use elimination. It's the third way. All right, now what does the word elimination mean? Take away, take out, what else? Erase, delete, to get rid of something, right? We're eliminating it. We're making it go away. So that's basically what we're going to be doing here. All right, so first problem. The general idea of elimination, okay? Number one, they're both going to be set up in standard form, which these are. Remember standard form, ax plus by equals c? Okay, what we want to be able to do is we want to be able to put a big plus sign over here, draw a line underneath, and we want to be able to add these terms up. You see how I have them all lined up? The x's are in line, the y's are in line. So if I do x plus 5x, what does that give me? 6x. Negative 2y plus 2y is 0. So equals negative 19 plus 1 is negative 18. So I actually eliminated my y variable. That's what we're wanting to do. We want to have it where if we add it up, one or both of the variables is going to cancel. So now from here I have 6x equals negative 18. What would I need to do?
Divide by 6.
Good. Divide by 6. So x equals? Very good. Okay. Which one do y'all want to fill it back into? Top one? So if I have x minus 2y equals negative 19, that's going to give me negative 3 minus 2y equals negative 19. So what would I need to do? Good. Add 3 to both sides. Negative 2y equals negative 16, and then by negative 2. So y equals? Okay, is this a all real number, no solution, or one solution? How many? One solution. And what's a solution? Negative 3, 8. Perfect. Pretty simple? Okay, go to number 2. Okay, if I put my big plus sign and I go to add these things, 3 minus 2 is 1x. 4 plus 4 is 8y. Did I eliminate anything? No. So really, this is not going to work. You see what I'm talking about? Nothing was eliminated. So what we want to do is we've got to change one of these. Is there any simple solution you guys have? I'm going to tell you it involves multiplying. We still want to eliminate. What could I do? No, we're not going to substitute. We're still going to eliminate. Nope. Think about it. When I eliminate things, one of the numbers is positive, one of the numbers is negative, but it's the same number, right? So like a negative 6 and 6. So do what? Multiply one of them by negative 1. Okay? If we have a positive 4, what would be the easiest thing for this to turn into? negative 4. And it doesn't matter which one's positive and which one's negative. You can do it to the top one if you want. But if I did the bottom one, so if we're going to multiply the bottom one by negative 1, okay, what I want you to do is I want you to rewrite the top. So 3x plus 4y equals 18. And the bottom one will be positive 2x minus 4y, very good, equals negative 8. Okay, now if we add them together, is one of them going to add up to 0? Yes. So this gives me,
5x equals
very good, 5x equals 10. Then what? Divide by 5 so that x equals 2. Okay, which one do y'all want to fill it back into? The top one? So if we have 3x plus 4y equals 18. When I fill it back in, I have 3 times 2 plus 4y equals 18. So that gives me 6 plus 4y equals. Now I need to subtract 6. So I have 4y equals 12, and then, good. So y equals, how many solutions? One solution, and what is it? Good. Okay, let's skip 3 and go to 4. Okay, number 4. What's going on here? Can you just multiply by a negative and fix it? No, because you don't have the same number, right? Your x's, you have a 7 and a 5. Your y's, you have a 12 and an 8. So any ideas here? Okay. If they're not the same number, how would we get them to be the same number? Good. Common factors, right? So 7 and 5, what's their common factor? 35. 12 and 8, what would be their first common factor? 24. Okay, it doesn't matter which one you want to change. Do y'all want to change the x's to eliminate or the y's? X. Okay, so we said our common number was 35, right? Let me get this here. Okay, so our common number is 35. So the top one's going to multiply by 5. The bottom one's going to multiply by 7. Does that fix all of our problems? What problem did it not fix? They're both still what? They're both still positive. So what do I need to do? One of them needs to be negative. Doesn't matter. No. So which one do you want to make negative? The bottom one? So we're going to multiply by negative 7 then. So my top, 5 times 7 is 35x minus 12 times 5, 60y equals 5 times 22. 22 and 5, that's a 10, right? And 11, so 110. The bottom one is negative 35x. Negative 7 times negative 8. Huh? Positive 7 times 8 is 56. Do what? Which one are you talking about? Yeah, you're right. Sorry. You're right. Negative 110. And then equals negative times negative is a positive, and 14 times 7. 4 times 7 is 28. So we have 7, 8, 9, so we have 98. Okay, now let's add. My x's make 0. Negative 60 and 56. Negative 4y, very good. Negative 110 and 98. Negative 12. The bigger one is negative, right? 98 to 100 is 2. And from 100 to 110 is 10, so 12. Now what? Divide by? Good. So y equals 3. Okay, which one do you want to fill it into? The bottom one, the new or old? This one or this one? The new or the old one? It doesn't matter. If I were you, I would go through the old one because the old one's got smaller numbers. Right? So if you pick the bottom one, so we have 5x minus 8y equals negative 14. I'm going to fill in y of 3. So 5x minus 8 times 3 equals negative 14. You guys staying with me? Okay, so my next line should say equals negative 14. Good. So 5x equals 10. And then x equals how many solutions? One solution, and what is it? 2, 3. Okay, problem number 5. What's going on here? What do I need to do? Do they add up to 0? Do I need to multiply one or both? One. Which one? The top one or the bottom one? The bottom? What are we going to multiply it by? By 2? Okay, so let's rewrite it. Top one was 2m plus 6d equals 12. Do they use x and y? Does it matter? No, just so as long as they're lined up together. You guys see that? Okay. The bottom one should say Very good. Good. Our big plus sign over here. What do we got? 0 equals 0. True or false? True. So is it no solution?
Yes.
So there's no number you can put in for M and B that will make this true? Any number you put in for M and B will work, right? So it's all real numbers. If it's true, you can fit in any number. If it's false, there's no number that will make it work. So true is all real numbers. Or you can do the double-backed R. What kind of graph did this look like? You guys are close. You're throwing out C words. Coinciding. Coinciding lines. Parallel lines. I heard somebody yell out parallel. Parallel lines. Do they ever touch each other? No. So will there be a solution? No. Okay, coinciding or on top of each other. All the numbers work. Let's look at number 8. Okay, what do y'all want to do? That's not number 8, number 6. Sorry, it's on slide 8. It's number 6. Sorry. Tricky. Multiply the top by 2. So that gives me okay. The bottom one, 4x minus 2y equals negative 14. Will that work? Should, right? What does that give me? 0 equals 4. True or false? False. So what's the answer? No solution. There is no number you can put in for x or y that will work. It will always come out no solution. So what does this graph look like? Okay, write it down. Parallel lines. Okay, let's skip to the back. And I want to go to number 8, last period. That's the one they chose, and I thought it was a good question. So let's do that one. All right, each family in the neighborhood is contributing $20 worth of food to the neighborhood picnic. Okay, so let's write down all the things we know. We know each family brings $20 total, right? The Knight family is bringing 12 packages of buns. So Knights they've got 12 buns. Hamburger costs $2 per pack, right? And we know the dogs are going to be $1.50 per pack. So what exactly is it that I'm needing to find? What do I need to find here? how many of each, right? So we can use H and D. We can use ham and dogs, right? Let's make H, what do we want to call it? Not just hamburgers, because we know the price. What do we need to know? Number of hamburgers, right? And the D will be the number of hot dogs. I'm going to help you with the first one. Okay? They're giving us numbers of buns and they're giving us cost. Right? So one equation, let's make the first one for the total number. What was the total number of buns? 12. How many buns did they bring? 12. But what went into the 12? If I'm counting up numbers of hamburgers and hot dog buns, do I need to know the cost? If I know that I have 12 in my package, I've got a total of 12, does it matter how much they cost? No. All I need to know is that she brought hamburger and hot dogs. So the number of my hamburgers plus the number of my dogs is going to total 12 total. Does that make sense? So then the second equation would need to be for total cost. Then I'm going to need to write what? The price of each. So $2 times the amount of hot dogs or hamburgers plus $1.50 times the number of dogs is going to give me a total cost of 20. So does that make sense? Yes? Okay, so what I want you to do, since we have this set up, if you ever have that kind of problem, that's how you're going to set it up. One's going to be for the total amount, the other one's going to be for the total cost. Alright? Total amount, you don't need to know how much. You just need to know what made up the total amount. I want you to finish this problem and I want you to finish this worksheet for homework. Okay?